Hi, I'm Dr. Faizwan again. Now, I am going to explain to you about our experiment number 3, which is determination of zinc by linear calibration and standard addition methods using atomic absorption spectroscopy. The machine besides me. Atomic absorption spectroscopy is a technique for determining the concentration of metal element or mineral in a sample. The technique can be used to analyze the concentration of over 70 different metals in a solution. It uses absorption or emission spectrometry to assess the concentration of analytes in samples. Electrons of atoms in the atomizer are promoted to higher orbital for a short amount of time by absorbing a quantity of energy at a given wavelength. This amount of energy or wavelength is specific to a particular electron transition in a particular element. This gives the technique its elemental selectivity. Quantitative analysis requires accurate and reliable measurements that relate to the composition of the sample. In instrumental techniques, the proportionalities need to be practically established in the calibration procedures. In a typical simple calibration, a range of standards is prepared containing varying amount of the analyte. So now we are going to use this technique to determine zinc in our sample using AAS. The first step of this experiment is the preparation of the stock solution. We require 1000 ppm of zinc. This can be done by measuring 0.44 grams of zinc sulfate to the nearest 0.1 milligram with 4 decimal places. This is what I'm doing now. I'm transferring the standard into the beaker and weighing. Now I get the amount that I require, 0.44 grams. The next step in this process is to prepare the solution. I am going to dissolve the 0.44 grams zinc sulfate in 100 milliliter of deionized water for dissolving the salt in the ionized water. Stir it, right, to make sure that it is homogeneous, right? And then the next step, of course, after preparing this, I have to transfer into 100 milliliter volumetric flask. Right. So now let us prepare this first. Okay, we stir. Right. Then get our volumetric flask. Then we can start transferring the solution into 100 milliliter volumetric flask. This is how it is going to be done. Then we add distilled water, deionized distilled water, into the volumetric flask up to the mark. We have to be very careful. We have to make sure that we have eye level observation. Now, okay, since it's coming to the mark, I have to stop it. I have to make sure that I am at the level. Right. Now I'm transferring small amount using dropper, small amount of deionized water using the dropper to make sure that the meniscus attains the mark that I want. Now, it's about it. I think we got it. Yeah, just a little bit. One more drop to go. Yeah, that's it. Fantastic. Now, put up the cap and make sure that you mix the solution by flipping this up and down for several times to make sure the homogeneity of the solution prepared. Now you have the 1000 stock solution. Since we have done preparing the stock solution of 1000 ppm zinc, the next step is to prepare the working solution. We need to prepare 10 ppm of working solution from the stock solution that we have prepared earlier. Now I'm going to show you how that can be done. So I am going to pipette certain amount from this standard stock solution that I prepared earlier. Right, I'm going to pipette that out. Okay, and I would like to transfer that amount of stock solution that I have prepared. Okay, let us get the volume into the next volumetric class. Right, well, you have to calculate that. I'm not going to tell you the amount. M1V1, M2V2, guys. Right, so since I have already transferred a certain amount of the stock solution into the next volumetric class, now I'm going to fill up the volumetric class with distilled water. Right up to the mark, the same process that I demonstrated earlier. Right, so upon attaining to the mark, I should be able to get my 10 ppm working solution of zinc. Alright, just pipette a little bit more to make sure that we get to the mark. Okay, a little bit more, maybe a little bit more. Right, I think a few more drops maybe. Okay. Okay, a little bit more. A little bit more. Carefully, make sure that you get the meniscus right to the mark. Okay, I think I got it. Now, I have to cap this volumetric flask, and the same process I have to flip upside down several times to make sure that the solution is homogeneous. Now I have the working solution of 10 ppm. Next, I'm going to prepare the calibration standards, right? So I'm gonna need 5 different volumetric flasks because I have to prepare 5 different concentrations of calibrators at 0.5 ppm, 0.4 ppm, 0.3, 0.2, and 0.1 ppm. Right, so to prepare this, I have to prepare using serial dilution. I'm going to take certain amount from the stock solution and transfer into the first volumetric flask to prepare the 0.5 ppm, and then transfer certain amount from the first volumetric flask to the second volumetric flask to prepare 0.4 ppm, and then to the next. Alright, so using the serial dilution process. At the end of the day, I'm going to have 0.5 until 0.1 ppm. So these are the calibrators that I'm going to use to prepare my calibration curve for determination of the zinc. The next step is I'm going to prepare the standard ensample for standard addition method. I'm going to transfer 20 ml from this sample into every single volumetric flask here. And then I'm going to make up the concentration to X plus 1 ppm, X plus 0.75 ppm, X plus 0.5 ppm, X plus 0.25 ppm, and X plus 0.0 ppm by adding certain amounts of volume from the working standards that I prepared earlier. The volume will be made up to the mark using distilled water, and you have to be very careful when you are doing that to make sure that you get the meniscus right on the dot. Now, I think we are ready to perform our AAS analysis. Come, let's go. We go to the AAS machine and do the analysis. Come, follow me.
Assalamualaikum dan salam sejahtera. Nama saya Zaini bin Ishak, telah bekerja di TM ini selama 30 lebih tahun. Dan apa yang saya nak katakan di sini, sebelum anda prepare bahan-bahan anda perlulah menjaga SOP preparation, safe procedure, di mana kamu kena guna PPE, kena guna goggles, mask dan glove, ya. Dan apabila datang di sini ada SOP penggunaan alat supaya untuk menjaga jangka hayat alat ini, ya. Dan alat ini namanya Perkinema model AAS 400. daripada perkiraan EMA analysis 400. Okey. Dan sebelum anda onkan semua, anda kena jaga SOP alat ini, di mana bukakan gas SC2H2, di mana acetylene digunakan, gas acetylene, dan onkan device instrumen ini, dan PC onkan sini. Onkan alat ini dan PC, dan selepas itu kita onkan kompresor di luar, iaitu oksigen yang akan membantu pembakaran. Dan sebaliknya, bila nak tutup, kita offkan sana kompresor, device dan PC, dan barulah device dan gas. Dan sebelum untuk menganalisis, kita bukakan fume hood ni, sebab kita berada di dalam keadaan yang boleh kata bahaya, di mana kita menggunakan logam-logam berat. Dan di sini saya terangkan bagaimana fungsi alat ini. Alat ini berfungsi untuk menentukan sesuatu kepekatan logam yang kita tidak tahu, tapi kita tahu logam sebenar. Katakan kita nak cari zinc, kita dah tahu zinc, dan tapi kita tidak tahu kepekatannya sebenar. Dalam di sini menggunakan unit ppm. Dan di sini saya terangkan perkakasan alat-alat ni. Ni dipanggil nozzle. Dan keseluruhan ni dipanggil chamber. Depan nozzle ini ada satu berbola bead, dan depan berbola bead ada spoiler, di mana bila dia menyedot, dia akan mengatomize seperti kamu gunakan perfume atau paints atau spray cell top. Bentuk dia begitu. Dia akan mengeluarkan satu percikan yang sangat halus dan smooth. Dan apabila dia sedut di dalam chamber ini, dan atom-atom tadi akan teruja, dia akan chopping daripada dalamnya. Dia akan teruja, atom-atom terhasil dan terbebas di atas ini. Dia akan putuskan rantaian atom, dan atom-atom tadi akan terhasil di atas. Dan kita gunakan source. Kita nak cari zinc, kita gunakan lamp zinc. Sebaliknya, kalau kita nak cari cadmium, kita gunakan lamp cadmium. Ini dipanggil hollow cathode lamp, di mana dalam dia ada anode dan cathode cadmium lah. Kalau kita guna zinc lah. Hollow cathode lamp. Di dalam ini ada 4 housing, tapi kita boleh gunakan satu dalam satu masa. Dia tidak seperti IC PMS, dia boleh gunakan satu saja. Okey. Dan bila atom-atom tadi telah teruja di atas benda ni, dia panggil gas benda, di mana kita gunakan lamp cadmium. Cadmium tadi akan menyerap cadmium saja. Kalau yang terbebas itu cadmium, plumbum atau sebagainya, dia sebab kita nak cari zinc, dia akan serap zinc saja. Bila dia nak absorb, dia akan hantar ke detektor di sini, dan terus dia hantar menjadi spektrum. Dan data-data ini akan anda olah balik menjadi membuat laporan dengan kepekatan yang sebenar, di mana anda akan mencari YNX campur C, keceronan yang sebenar yang akan anda laporkan. Buat laporan Dan rasanya tak ada apa lagi. Dan sekarang kita gunakan teknik flame, di mana dia menggunakan api. Ini dipanggil teknik flame. Kita ada 3 teknik, hydride dan juga graphite. Di mana jika anda tidak mendapat hasilnya dalam kepekatan ppm, anda boleh cari, bukan bermakna anda tidak dapat, tapi anda boleh cari dalam kepekatan yang lebih rendah, ppb yang menggunakan hydride dan graphite. So, di sinilah dia akan menyedot semua sampel-sampel anda ataupun standard semuanya dalam bentuk larutan, bukan pepejal. Dia akan menyedot seperti mana yang saya terangkan tadi. Dia akan mengatomize dan atom-atom tadi terhasil atau terbebas terudir di atas akan diserap oleh lamp zinc. So, dia akan hantar ke sini sebagai spektrum dan data-data anda akan olahkan semula di dalam Excel, baru dapat kepekatan dia yang sebenar. Sekian, terima kasih. Okey, ini adalah seperti mana setiap pengoperasi alat ini akan membuat satu kalibrasi yang sebenar. Kepekatan 0.3 ppm akan mengeluarkan bacaan setidak-tidaknya 0.18, dan sebenarnya 0.2. 18 dah memadai. So, ready?
Oh, tadi mop je.
Tadi mop.
Okey.